Alright, so today is where the fun officially begins and we're talking about actual functions. So back in grade 10, we've dealt with all of these transformations to, well, quadratic functions because that was only one we focused back on. So now we're going to deal with the same kind of set of transformations. We're going to do some vertical transformations, some horizontal transformations, some reflections, which is next class. But today we're just going to warm up with some reflections. So first, we're going to look at some positive vertical transformations. So in here, the question has asked us to graph y equals x squared and y equals x squared plus 2. So if you didn't remember back in from grade 10, plus 2 directly, that is just going to move the graph 2 units up. So on here, I have graphed it for you. Well, it's from the textbook. So we can see that these parabolas, they're basically the same. They're completely the same, in fact, except x squared plus 2 is basically y equals x squared, but it moved up 2 units. This is pretty simple. So I don't think we need to say much. Let's move on. Now let's compare these three graphs. So these are all the possible transformations that you can, well, the vertical transformations you can ever do to a function. Even years later, where you learn about complex math, this is still basically everything you can pretty much do to vertically transform a function. So right here we can see, originally we had y equals square root of x, so that we learned that last lesson. But now we have y equals square root of x plus 3, so it moved that 3 units up. So we can see originally it was at 0, 0. That was the vertex point, or the starting point. It was at 0, 0. So now it's 1, 2, 3. Now the starting point is 0, 3. It moved 3 units up. And here it moved 2 units down. So now it's 0, negative 1, negative 2. So that is pretty much it. And now I'm going to talk about horizontal translations. Horizontal translations are basically the ones that move along the the x-axis. So right here, you have y equals originally the y equals square root x, and y equals x plus square root x plus 2, y equals square root x minus 3. So when you look at this, you see that this 2 is outside of the x, it's nowhere near the x. However, these are actually inside near the x. It's in the bracket, it's near the x. So that is an an x transformation. However, x's are weird. They're stupidly weird. They're always the reverse. So, for example, when we have x minus 3, we can see it's 1, 2, 3. It actually moved 3 units to the right instead of minus 3 becoming negative 3, 3 units to the left. So that is a little weird. I want you guys to keep that in mind. You probably learned that in grade 10, grade 9. But again, it's a little weird, so keep that in mind. And then for x plus 2, it's actually 2 units to the left, which is square root of x plus 2, and move 2 units to the left, which is now negative 2. Now, with all that said, it's been like a minute. I want you to go ahead and sketch this horizontal translation, this little parabola for me. If you can pause and do that. Okay, give you 5 seconds. Okay, cool. So, right here, I will show you my answer. This is my answer. So originally we had our vertex point at 0, 0. Now it has moved to 3, 4. So basically what happened in here, it was that we moved 3 units, negative 3. Remember, minus 3 actually means we're moving to the right. 3 units to the right, and 4 units up. So that is all the transformation that happened here. Should be pretty simple. Yep, and that's it. So you might think that's the end of this class, which you will be correct if I wasn't a great teacher. So I'm actually going to introduce you to one of the fundamentals that you're going to deal with for the rest of pretty much rest of this course and the next course. So I'm going to give you the general form. So I use AKHP, but some teachers might use different ones. Textbook might use different ones. So this is a vertical, this is a flip. So this is flipping, whether that is so, or if you want to use a better language, this is reflections. flexions. And this is what we just learned. Vertical translation. And here, right here, we have the H. This is the horizontal translation. And over here, this is our horizontal I'm not going to write that much. Horizontal stretch. And over here, we have our general form. This is our general form. So you might look at it and be like, hey, what is this? So remember, originally you have y equals f of x, right? So now you can plug basically everything in there. That's a part of f of x. So if I had, let's say, the square root function that we've been using this class, it would be something like this. So right here inside we have our horizontal translations, vertical translations, and these two I'm going to talk about next class. And then you can plug it in for everything. So you can do a, and then, well, okay, you need this bracket, okay, x minus h squared plus p. And this, we have our quadratic function. So basically, this is the general form, and these were the translations, these were the stretches and compressions. So this is a general form that is going to be very useful to you throughout the course. And I also want to go ahead and introduce ourselves to something called a mapping rule. So we're going to actually formally learn about this a couple lessons back, well, a couple lessons later, but I just wanted to introduce it right now. So originally, when we had this parabola y equals, oh, why am I not writing again? When we had this parabola y equals x squared, this has its vertex point. It's gonna be at 0, 0, which is basically the origin, if everybody knows. So, however, we can look at the let's just use this one as an example, because why not? So let's just look at it, and we can see like, oh look, it's 3 units to the right. So what does that mean? It means O of our x value is going to become x plus 3 now. So our x value is going to be x plus 3. And we move 4 units up. So what does that mean? O of our y values are going to become y plus 4. So now originally we had 0, 0, right? Originally this was, okay, sorry. This was the original x and y. So originally we had 0, 0. And then we had 1, 1. 2, 4. That was our quadratic. And now we look at it and be like 3, 4. And now it's 4, 5. And that's 5, 8. And if we look at this graph that I graphed for you earlier, we're like, hey, look, these are the points here. 5, 8. What else? 4, 4, 5. And then 3, 4. So using this mapping rule that we were able to derive from this function, we're able to actually graph the entire thing with precision. So that is pretty much all I have to say this lesson. Should be very straightforward. If you have any questions, email me, leave a comment, whatever you do, try to find